All right, so I received a couple questions about the servo code, and I wanted to make sure that everybody could understand it and review this at their leisure. So this code here is the demo servo code from Google Classroom. This is the second tutorial series for Introduction to Computer Science. The very first video was on digitally reading the button pins, so we could just do some basic logic to turn on and off an LED. Today we're going to go a little bit further and look at how we created code that was allowing our motor to sweep. So starting from the top, we have our include here. An include is a library, right? So this is a reference to pre-existing code that allows us to make use of an existing device, allowing us to access more commands that would come in just the base IDE or our integrated development environment here. So we're including the Servo library. You can either remember how to insert this, or we can go up to the tools and we can go to um, oh, I apologize. It's actually under the sketch option, include library, and we can go down here and we can find the servo category, and we could just include it that way. So you see that's the same option, but you only have to do it once. So by referencing this, this allows me to use commands such as servo. So servo here allows me to create a motor, right? So servo is the type, much like integer, but we're just naming it motor. I can name this whatever I want, right? I could replace this with dog, cat, whatever it is, but today we're just going to name it motor since that seems to make the most sense. Just like our previous code, we have our button pin set up here, and we have our servo pin set up into 3. Very good. If you remember, our servo has 3 wires that come through it. We have the red wire, which is our positive, our brown wire, which is our ground or our neutral, and our servo pin, or our trigger pin, is what our pulse is actually coming from our digital port. So in this case, we're going to use the number 3. We go to our void setup, and a lot of it's the same old. So again, we always use serial.begin so that we can start up our serial monitor, which we launch from the top right up here. Motor.attach is kind of like in our previous code when we did the pin mode. Remember we did that, and we would specify a pin, and then if we wanted it to be an output or input, this is the same idea, but we're setting our servo up to receive the 5-volt power that it needs to actually rotate. Since you need a really good signal that's consistent in order to make the thing rotate 180 degrees. We start off by writing our motor to 0 degrees just so we have a baseline at the start and a very brief delay. Whenever we write our motor, we always want to have a short delay. You might remember from class, we used 250, right? So 250 was our response time for a human, right? For a button. We just use 10 milliseconds to give our servo time to not really catch its breath, but enough time to rotate to where it is so we don't overload it and it doesn't burn out. So that's a really good idea there. You might also see us use 25 sometimes. That's totally all right. For our purposes, we're just going to use 10. Void loop, again, this is where everything runs repeatedly, right? So we go from the top, just refresher, this runs once. We go to our void setup, this runs once, and then our void loop runs repeatedly. We're asking the question, is our digital read of our button pin equal to 1? Now this line here, right, might seem a little unfamiliar because usually we're asking for a button state, which is fine. Usually on the previous line, we'll set button state, right, equal to a digital read of our button pin. All we're doing is we're simplifying this by taking this whole line right here and just putting it in our if statement. When we started out, we had button state as a variable to get you in the habit of creating variables and saving that information. When you work a little bit faster or you feel more comfortable with the program, you can take small shortcuts like this, which is totally acceptable. It actually saves you lines of code, making your code more efficient. So we're taking just the whole read right there, and we're putting it into the if statement. So remember, if the button is pressed, that's a 1. If it's not being pressed, it's a 0. So if it is being pressed, we're going to go ahead and write our motor to 178. If this was a standard China servo, 180 would be our max. The servos we got are a little bit nicer, so we can rotate 360. So we were just being cautious before and going just below the 180. Since we do have the nicer servos, we can replace that and go to the full 180. That is not a problem. Again, like I said, always delay that 10 seconds and you're good. Otherwise, right, if the button is not being pressed, we would like that to rotate to 0. Okay. If you have any questions about this, you can feel free to email me, but this is basically the entirety of our code. I do notice an issue that was published here. There is a random dash here at the bottom. This is not supposed to be there, so I apologize for including that, but everything is all right. One refresher before we go, when you click next to your brackets do have that little box there. This is an issue I continue to see in code, so make sure that you have your top bun and your bottom bun of your sandwich, so your subs are fully closed. Um, to help make sure of that, you can go to the auto format, which will fix any issues you have. If, for example, I forgot to indent these or these were really wonky and I really messed some stuff up, the tools and then auto format allows my code to look a lot neater. So it's easier to see which ones line up with each other. Anyway, I hope that this helped. Feel free to check out the other videos as they come. Thanks very much.